Hi guys, Ben Hurley here, and today we're going to do our first bit of coding with the Arduino. So let's go and have a look at the introduction on the lesson on the website. We've got just a little bit of a reminder about some of the pins on the Arduino. One good way to think about the Arduino is a kind of on-off switch. If you remember that lesson where we created a simple LED circuit where we could turn the LED off and on by pressing the button on and on. Imagine that the Arduino is doing the job of the switch, and instead of using our finger, we're going to be doing that with the code that we write. Okay. Now, the cool thing about Arduino is that we can be very versatile. We can hook up any kind of hardware that we want to these header pins along the top. They're the digital pins. So any kind of digital type hardware, like on-off type of things, like LEDs, you can turn them on and off. Buttons, you press them on and off. Buzzers, you can turn them on and off. All those type of things, we can hook them up to those pins and then start controlling them in the software. It gets even easier to get started because, just to help us out, Arduino actually already has a little teeny tiny surface mount LED inbuilt on the board. Now, the one that we have in our kit looks a little bit different to that. It has a different processor. I'll just go back up to the big view again. It's just in a slightly different position down here. You see that flashing LED, and it's got a little letter L next to it. That's our built-in LED, and that is connected automatically to pin number 13. So whatever we do to pin number 13 in our code, if we turn it on, that LED will turn on. If we turn it off, that LED will also turn off. So let's dive right in and have a look at our first bit of code. Now go ahead and open up your Arduino IDE like I have over here, and this is just a blank sketch. It will open up automatically to get you started. Now this doesn't do anything, but it gives you the bare bones of how every Arduino program works. We've got two main areas. In the first bit here, I'll just highlight, we've got what's called the void setup. Okay, don't worry so much about the void part, but this is the setup area. Anything that we do to set up initially for a one-time operation at the start of the program, we put that in the void setup. And so whatever code that we put in between these curly brackets here, you can't see my cursor on this view, but those two curly brackets, whatever we write in between there happens in the void setup. And then underneath that, we've got the void loop. And this little section, whatever code we write in between the curly brackets here and there, that will get looped around and around and around. The Arduino will do everything inside those brackets again and again and again and again as fast as it can, and it can do things pretty fast. Okay, so the first thing we want to do to use an LED is we need to set it up. And we do that by going, and we always indent over. It's a really good programming practice to write inside brackets tabbed over. Some programming languages rely on a tab to make sure things are working correctly, like Python. Arduino doesn't, but it's still a good practice to indent with a tab when you're inside a curly bracket. Okay, so we're going to set up our pin 13 as an output, and the command is pin mode. Now see how that's gone red? That means that's a recognized command in Arduino. That means we spelt it correctly. And particularly pay attention to the capitals. If I did pin mode lowercase m, it doesn't go that red, because that means that it's not, that's the completely different word. Arduino completely doesn't recognize it. It's complete nonsense to Arduino. It's got to be pin mode, little p, capital M, like that. And we do a brackets. We've got to tell it what pin we're going to set up. And we're going to set up pin 13. And we also have to tell it whether we're doing it as an input or an output. So that would mean, are we accepting information in, or are we putting information out? Think about the Arduino as, don't think about the Arduino as this whole thing. Think about the Arduino as just that little microprocessor chip right there. That is Arduino, and all the stuff on the rest of the board is all external stuff, external to Arduino. So this might be a pin that's built into the board, but it's actually external to the processor. It's external to the Arduino's brain. So what we're going to do with Arduino is we're going to send electricity out of Arduino into the LED. So we're going to set up our LED pin as an output. The other way you can, if I can spell, O-U-T-P-U-T, output, it goes blue. That means I spelt it correctly. And the capitals are important. If I just write output, lowercase, doesn't like it. It's got to be, one of these days I'll learn how to spell output. Very good. Okay, so we're telling Arduino that we're setting up a pin mode. We're setting pin 13 to an output mode. So we do the pin number, comma, whether it's an output or an input, and we put that inside brackets, and just about every single Arduino command ends in a semicolon. That just tells Arduino that that's the end of that line, that's the end of that command, and that the next thing is on a new line. Okay, and then what we can do next is we've set it up as a output, and then we can turn it on. So if we go down into our void loop, we'll tab over, we can put it in the loop or the setup. The setup will do it once at the start. The loop will do it again and again and again forever until the Arduino turns off. Either way, it doesn't make a difference. If we're turning the LED on and on again repeatedly all the time, that's fine. We can do it that way. So the way we want to turn a LED on is we want to hook it up to a battery, right? The way we've been doing it with electronics, we have to connect the path through the wires to the power source. So we want the LED to be connected to the high end of the electricity, the positive, and in Arduino land we go digital write, that's the command, and it goes red because we spelt it correctly. We tell it what pin we're writing to, pin 13 is our LED, and we tell it high or low. High is we send 5 volts to it, and low is we send 0 volts to it. Or we can think high is we connect it up to the positive side of the battery, or low is we connect it up to the negative side of the battery. So we're going to set it to high, close bracket, end the command with a semicolon, and we can run that sketch right away. We can press upload. It's going to ask me to save it. I'll just quickly save it somewhere random. How about desktop? I'll just call it LED test. That'll do. Compiling. Oh, there's an error. What did I forget? I know. I moved my Arduino over to a different USB. So I just have to go to tools, and just select the port again. Okay. So you've got to make sure that you connect up to the correct port, and the port changes if you change your USB port. Okay, done uploading, and now my little LED is just holding steady on, because about hundreds and hundreds or thousands of times a second it's sending that command, looping again and again and again and again, telling it to turn that LED on. Okay, that's pretty simple. Now what if we wanted it to flash on and off? Okay, we want it to turn it on, and we want it to turn it off, on, off, on, off, like that. Okay, so let's go back over to our code, and we can turn it off. Remember we said that if we do a digital write but say low, that connects up the LED to the negative side of the battery, connecting it up the wrong way around. And we learnt that when we connect an LED up the wrong way around, it doesn't turn on. So let's do that. Digital write pin number 13, whoops, and we want low. Goes a nice blue happy color, close brackets, and semicolon to finish the command. Let's upload that. And compiling, uploading, done. Okay, so compiling means that the programming program, this program that we're using to write our program, is translating. It's translating this code that we're writing into code that the Arduino understands. Okay, so let's have a look at what we've got. We don't have a blinking LED like we thought we might. We've got a I'll get a close-up look there. We've got our LED on, but it's dim. This is the power LED up here. It's nice and bright, but our LED down here that we're turning off and on again, it's sort of on, but it's sort of dim. Okay, so it's not blinking like that, like we wanted. Okay, what's actually happening is that it is turning off and on again, but it's turning off and on again as fast as the Arduino can, which is faster than the human eye can see, and it just looks like it's half on. Okay, so it's on half the time and it's off half the time, as fast as it can, faster than we can see, so it looks like it's half on to our human eye. So we need another command to slow things down so that we can actually see it, and we use the command delay. So I'll go delay, goes red because it understands it, and we just put one thing in the bracket, which is how long we want to delay for in milliseconds. Okay, and there are 1,000 milliseconds in a second, because milli means 1,000th, or divide the thing up into 1,000 parts. Okay, so 1,000 milliseconds in 1 second. So it's going to turn the LED on, wait, do nothing, delay for 1 second, 1,000 milliseconds, then turn it off again. Now, if I just do this, it's not going to work, because as soon as it turns it off, it turns it straight back on again. So we need another delay to keep it off for a second so we can see that it's off. Okay, and now we've got on, delay for a second, off, delay for a second, repeat. So let's upload that code. Compiling, uploading. Here we go, done. And there we go. Now we've got our LED down the bottom there, flashing full brightness, turning off and on again for 1 second. And we can play around with that number. If we don't like a second, we can change it. We can change it to half a second by going 500. What if we just left it like that? We could turn it on for half a second and then have it off for half a second. Let's have a look what that looks like. So we can control the way we want our LED to behave however we like. There we go. On for a bit, off for longer. On quick, off long. Just doing a short blink. Short blink. Okay. So that's it. That's pretty simple. Now on the website, I've got a couple of challenges for you guys to try. Just scroll down to the bottom. This is all just description of what we've just done. Example program, turning it off again, blinking on and off, adding in your delays. Okay. Now where did I do the challenge? The challenge is in the next lesson when we hook up a real LED. I'm going to give you a couple of challenges at the next lesson. Okay, so try that out for yourselves. Have a little play around with the parameters, and see how you like to blink your LED. If you like to blink it on for a little bit, off for longer, or the other way around, make blink on for a second or two and off a little bit. Yeah, play around, see what you like, see if you can come up with some cool. You could do different things. You could come up with different combinations. You could blink some messages, or fast, 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 slow, slow. You could do a little bit of Morse code like that, and have a play around with it. And I'll see you next time. Thanks, guys. Bye.